Now let's talk about area formulas. Again, we'll be computing area as well as solving for an unknown side. So the definition of area is that it's a form of measurement that uses square units. In this example, I have a rectangle, a length of 3 and a width of 2. And so if I were to create 2 rows of equal size like this and 3 columns of equal size, when they intersect, you can see squares. And so if we were to count up these squares, I have 6 of these square units or square feet, and that would represent the area. So we're always going to be looking at the surface of a figure and determining how many square units we can fit in there. And the square units will be based off of the unit of measurement given. It is a two-dimensional form of measurement, and our unit of measurement is always going to have an exponent of 2. That tells the reader that this number represents area. These are the formulas that we'll specifically be looking at in this video or in this presentation. So the first area formula is for a square, and this says area equals side squared. Because all of the sides are going to be the same in a square, we just need one dimension, which is the side dimension. We're going to plug in that amount into the formula. 9 squared is the same thing as 9 times 9, which will give us the 81 inches squared. I've got some examples here that are in decimal and fraction form. You're basically just plugging in those amounts into the formula, and when you're squaring, you're basically multiplying that number to itself 2 times. Now in this example, you're given the area amount, and we want to determine what the side dimension is. You plug it into the formula. A is the 64 equals side squared. That's our unknown. Now to solve for this particular problem, because we're squaring a number that's unknown, the inverse operation would be to take the square root of that amount. When you're taking the square root of a squared number, you're basically eliminating that exponent. And so the square root of 64 is going to give us 8 feet. Now let's look at the area formula of a rectangle. That's going to be area equals length times width. So for computing, we're basically just multiplying the length and the width together, and it's pretty straightforward. We're just multiplying those 2 dimensions together. To calculate the length or the width when given the area, we'll plug in the area amount into the formula that will be on the left-hand side. 96 will equal 12 times W. To solve for W, we want to isolate. We're going to divide both sides by 12, giving us our answer for the width, which will be 8 inches. Area of a parallelogram is similar to area of a rectangle. What's different is how we're labeling the sides. Instead of labeling this as the length and the width, we're going to have the base and the height. Okay, so when we compute the area, we're just going to plug in the numbers that are given, and we're just going to multiply. When we compute the height, compute for the height when given the area and the base, we're going to plug in 72 as the area equals the base, which is 9, and the height, which is our unknown. Looks like we need to divide both sides by 9. That will give us the value of our height. So here we have the area of a triangle formula. I've seen it written differently as base times height divided by 2. On the formula sheet, it's written as 1/2 times the base times height. Either formula will give you the same result. Now, this is an illustration of a right triangle. There are other kinds of triangles that you might see. For instance, you might see an equilateral style triangle that looks like this, where all 3 sides are the same. This would be your base. Your height might be marked in the middle like this, or you might see some extension lines, and then your height would be marked over here. This would be the height. You might also see like an obtuse type of triangle, and again, the height would be this dimension here. This would be your base. The main thing is that the height is always going to be perpendicular to the base. So to calculate area, you're just going to plug in all the information. The operations occurring here are multiplication. So 1/2 times 10 times 7. 1/2 of 10 is 5 times 7 is 35. Then we have, say we're given the area and the height, but we want to figure out the base. Again, we'll just use this formula to plug in what we have. Now you can multiply here 1/2 times 9. This is applying commutative property, meaning order doesn't matter when you're multiplying. And we're going to get 4.5 times base. And then, of course, we'll divide both sides by 4.5. Next, we have the area of a trapezoid. Now, an area formula for the trapezoid is 1/2 times the base 1 plus the base 2 times the height. So, in a trapezoid, you're always going to have 2 sides that are parallel to each other. So these 2 sides are parallel. The height will always be perpendicular to the bases. Now, in this example, the parallel lines are the top and bottom, but you could have the left and the right as parallel. Okay, now we are going to use order of operations when we're solving this problem, because notice we have multiplication, we have parentheses, and then we have multiplication. And we know that we need to solve what's inside the parentheses first, or simplify as much as we can before we do any other operation. So for computing the area, we plug in all the information. We have to solve what's inside the parentheses first, giving us 1/2 times 14 times 10. And continue with multiplying to get the area of 70 meters squared. Okay, now in this example, you're given the area, you're given the 2 bases. We have to solve for the height. Again, we're going to solve for what's inside the parentheses and then do the multiplication. Finally, we divide both sides by 5, giving us the measurement of the height. Okay, now let's look at a trickier problem. In this case, we have to solve for one of the bases, in this case, base 2. So we're given the area, we're given the first base and the height. Let's plug everything into the formula, and it should look something like this. Now, to simplify things a little bit, I went ahead and multiplied the parts that I can. And the reason I'm doing this is because I cannot add 20 plus base 2. I'm not able to simplify that anymore. So 1/2 times 4 will give me 2, and now I have 52 equals 2 times the quantity of 20 plus base 2. Now, what I'm doing here is I'm dividing both sides by 2 because I want to make this as simple as I can. Right now it's still a little complicated, and if I divide both sides by 2, I'm left with 26 equals 20 plus base 2. Notice I dropped the parentheses here. They're not needed anymore. In this case, I can now use the subtraction property of equality and subtract 20 from both sides. That will isolate the base 2, and that difference between 26 and 20 will give me the dimension for the base 2. This one was tricky. There was quite a lot going on in here, but it's good practice for applying different properties of equations. Okay, so for our last formula, we've got the area of a circle, which is area equals pi times the radius squared. Now, the radius, again, is that dimension that measures from the center of a circle to the edge of a circle. The diameter might be given instead of the radius. Just note that the diameter is double the size of a radius. So if you're given the diameter, just divide it by 2, and that will give you the radius. Okay, let's do some computing. So the radius is 10 centimeters. We want to plug it into the formula. Now instead of using pi, we'll use 3.14. This is an approximate number that represents pi. I believe on most of the questions on the GED test, you'll be asked to use 3.14. Just know, though, that pi is a more accurate number. Okay, 3.14 times 10 squared. 10 squared is the same as 10 times 10. Now we have 3.14 times 100, which will give us an area of 314 meters squared. Now let's compute the area when given the diameter. Again, we'll use 3.14. So since the diameter is double the radius, we're going to divide by 2, or you can multiply the diameter by 1/2. You'll get the same result. 3.14 times 1/2 times 6 squared. We're going to get 3. 3 squared is 9. And then when you do the multiplication, you get 28.26 millimeters squared. Okay, in this example, we're going to solve for the radius. So we're given the area. We want to know what the radius is. We're going to plug in the information that's given into the formula. And it looks like we're going to divide both sides by 3.14 to get rid of this number that's associated with the radius. And then we're going to get 100 equals radius squared. Now, we don't want the radius squared. We want just the radius. So the inverse operation of squaring is taking the square root, both sides. That eliminates that exponent. We're left with r. Square root of 100 is 10.